back today to talk about managing nitrogen as a system, carrying on with the monitoring of nitrogen and the different forms and avenues for loss. So today we're going to talk about immobilization, which is the temporary tie-up of plant-available nitrogen by the microbial biomass in the soil. It is the carbon to nitrogen ratio of crop residues or any organic amendments to the soil that influence the degree of immobilization. As carbon is added to the soil, microbial biomass responds to that food source, and if there's insufficient nitrogen content in that food source, it'll take nitrogen, free nitrogen from the system in order to grow and break down that organic matter and organic materials. And when that's completed, then they die off and release the nitrogen back into the system. So as a rule, materials with a ratio greater than 25 to 30 to 1 will immobilize nitrogen. And those materials that are added to the soils with 20 to 1 or 25 to 1 will mineralize and add nitrogen into the system. So our most obvious demonstration of that is in the Ontario Nitrogen Calculator, when a grain corn following grain corn recommendation usually puts about another 20 pounds of N onto the recommendation, and that's to account for the residue from the previous crop and be able to have sufficient nitrogen to break down that residue without the current crop suffering a nitrogen shortage. So when we look at adding organic amendments to our soils, we should consider getting a lab test done in order to understand the total N, the organic carbon, and the resulting carbon to nitrogen ratio. And as we add materials with very high carbon to nitrogen ratios, some production issues can arise and decrease the available N to the crop. So oftentimes the CN ratio materials will need additional nitrogen applied in order to reduce the immobilization of nitrogen. So here's a real world example from my former life. This is a manure sample was sent in mid-season after barley crop was doing poorly. Farmer had an opportunity to get this manure at no charge. So when we did the analysis, we found nitrogen at 0.56%, organic carbon at 30, and the carbon to nitrogen ratio at 53. So we know right off the bat a lot of immobilization would have occurred on this field. So if we divide the organic carbon by 20, we would get the N content that we would need to have a stable product. So that comes out to about 2.65% nitrogen. So if that's what we need to have stability in the system, then 2.6 minus the nitrogen content that was found, we need another 2% nitrogen in this material. So you do the math on a short ton, we need another 42 pounds of nitrogen or another 91 pounds of urea for every ton of this material that was used in order to reduce the immobilization of nitrogen away from the barley crop. So at 10 tons per acre, we would have had to have applied 910 pounds per acre urea in order to prevent immobilization of nitrogen. So this was a total crop failure. It was a post-mortem analysis, unfortunately, and lessons were learned. So as we move forward, if we're adding normal agronomic or agricultural products to the field, as long as they have 1% nitrogen, usually we don't worry too terribly much about immobilization. But as we get into the NASMs, the non-agriculture source materials, we don't necessarily know the origin. They're mixtures of materials together. So it's a good idea to have a CN ratio test done so we understand what it is that we're getting on our farm. It's better to be sure and know what you're applying in order to avoid unintended outcomes. And most importantly, we want to avoid post-mortem analysis of things that could otherwise have been prevented. So thank you for listening. Be safe, be healthy. Back at you tomorrow, and we'll talk about denitrification.